At the online live event to learn. I'm the host from AI Camp. Before we get started, just want to do a quick introduction on AI Camp. We are a global online platform for developers, engineers, and data scientists to learn and practice AI technology, with the mission of make AI available to all developers. AI Camp have grown to over 50,000 tech engineers in the group, have hosted over 300 local tech meetups, workshops, boot camps, large tech conferences, and live stream most of the tech talks globally. We have local study groups in major cities in the US, a few cities in Europe, India, China, Australia. You can take a look at the website to see our upcoming tech talks, workshops, and crash courses that we offer. We are very excited to have Jason, the CEO at test.ai. In today's talk, Jason will demonstrate how AI is directly applicable to all aspects of testing, apply neural networks, reinforcement learning to testing problems, and how AI makes test artifact reusable. Before we get started, just want to tell you a little background about Jason. He's the CEO at test.ai, where his mission is to test all the world's apps. Google's AI investment arm lead test.ai's latest funding round. Jason previously worked on several large-scale products, web search at Google and Bing, the web browser Chrome, operating systems such as Windows and Chrome OS, and crowdsources testing at eutest.com. So without further ado, let's welcome Jason.
Cool. Thank you for the introduction.
No problem.
Cool. Just share the window. I think we're sharing now. And I'll hit this magic present button, and it's all automated by AI. All right. Yeah, so my name is Jason Arbon, and I'm the CEO at test.ai. And I just kind of walk through everybody and show kind of latest advances in how people are, like we're doing here at test.ai, and other places and other companies are applying AI to the testing problem. Kind of gave my background. So I worked quite a few places, mostly focused on either machine learning projects or software testing my whole life. So it's pretty obvious that I would be doing this today. Also written a couple books that nobody reads. And like she said, we just had a funding round led by Google and by the AI part of Google. So this is the folks that actually do machine learning and AI at Google invested in our company recently. So let's get to it. So basically, everyone in the world thinks that their applications are these cute little snowflakes that are very specialized, very different than everybody else's app. But in reality, they kind of actually all look the same. Even these are different snowflakes. You can realize that it's awesome. That's my wife. And basically, like, they're basically all the same. Like, they all have the same. These are all radially symmetric. They're all white. They kind of all look the same, right? From a 10,000-foot view. But apps are the same. So I'm going to ask you a couple of questions. Just think about out loud as you walk through these slides. But if you look at these screens, and you may have never seen these screens before. In fact, I'm pretty sure you haven't because they're mocks. But if you look at it, they all look like login screens, right? They all kind of look the same. Your brain knows that within a second of processing, that it's got an email field, it's got a password field, a sign-in button. One has, they all have a forgot password link. They're basically all the same. So we'll talk about how this helps us with AI in a second. So if you look at this, these are 3 different ride-sharing apps, right? So this is Uber, Lyft, and Juno. And I don't even know Juno, but they all kind of look the same, right? But the reality of today is, without AI, these software teams at these different companies are writing from scratch. They start with a fresh, Ruby file or a Java file or a Python file from scratch, and they create their test cases independently. But they're testing pretty much the same app. But everybody recreates their test code from scratch because there's no reuse in testing today. So what I propose is that AI actually is a fundamental difference in testing. Like, we've tried to apply technology to do automation in the past. We've tried to do, with like web, there's cloud, there's, mobile, there's all these different technologies over the last, 20, 30 years, but none of them have really helped testing. They've actually hurt testing with fragmentation. But AI is a transformative way to write software. And it's the first time that these technology transformations are going to actually help testing. We'll walk through a couple ways that happens. And a key thing you'll notice in most of these approaches to AI is that, of applying AI to software testing, is that they build an abstraction layer on top of the application. Just like human brains build abstractions of applications. If you think about shopping apps in your own mind for a second, you know they all kind of have shopping carts, they have a search text box, they have product pictures with descriptions of the product on them, and they all kind of look the same. But you have, in your own mind, you have a notion, an understanding, an abstraction of what a shopping application is. So just like in testing, we're trying to get the machine to think and act like a human being, and that's why AI is specifically suited to the testing problem. Because it basically, AI lets you train a machine and a model to think like a person does. And in this case, for testing, it builds an abstraction of the application underneath it. So if you look at software testing, there's really two things that happen. Almost all testing boils down to this, especially test automation, which is you find elements in the screen, like you define the text boxes to interact with them or verify that they're there. And the second one is sequencing. So when you define and interact with elements in sequences, right? And that's a test case, is a sequence of actions. So how do we how do we basically reimagine these two aspects of automation with AI? So here's a picture, and ask yourself real quick, what are all these pictures of, right? And you've probably already answered in your own mind, these are shopping carts, even though you've never seen most of these before, right? And that's because your brain has generalized what a shopping cart looks like, right? Even the little number notifications don't throw you off, which direction it's facing don't throw you off. Some of these even sometimes look like baby carriages. It's kind of a cute shopping cart for different like baby shopping apps. But you know in your mind what a shopping cart is. And similarly with neural networks, we don't have time to do a full deep dive on the technologies underneath it. But you can, if you just show if you just show a bunch of shopping carts to a neural network over and over and over again, thousands and thousands of these shopping carts, it will also generalize. And if you give it a new picture of a shopping cart that's never seen before, it will go, I'm 99% sure that's also a shopping cart, just like your brain does. So again, for element selection, if you think about it, we basically we have a bunch of folders, right? They're just lots and lots of pictures, and not just of shopping carts, but of things like save buttons, search buttons, QR codes, play buttons, share buttons, search text boxes, all the different kind of common elements and applications. If you just get lots and lots and lots of pictures of them, you can train neural networks that will recognize them. Again, just like the person's human brain. So if you think about it, this is an approach to use machine learning and AI to do element selection. The second question is, how would we do test sequencing, right? So we need, in this case, to train a bot, an AI bot, how to walk through an application. So if I'd asked a human being and I gave them an app they've never seen before, and I said, go to the shopping cart page, right? They'd open the app, they'd look at what's on there, and the element identification, go, oh, well, there's a shopping cart, because we've done element selection now with AI, right? So now the AI can say, oh, that's definitely a shopping cart in the upper right corner, and a human would probably do the same. Well, that's a shopping cart, click it, and get to the shopping cart. But the beautiful thing about AI is that we don't have to explicitly tell it how to get to the shopping cart. So we've experimented with a bunch of different approaches. The one that seems most promising at this point is Q-learning, which is a form of reinforcement learning. And that's where you basically teach, like you teach like a pet, like say a dog, if it does something you don't like, you say bad dog. If it does something good, you give it a treat, right? And so what we do is we build an abstract representation of the application. And here's a picture of it on the right here. You got the home screen in the middle, and then there's connecting nodes, right? So you can get to the search page and get to the profile pages or product pages, and there's also a path to get to the cart. But what we want to do is, just like as a person, there's 4 different ways to get to a shopping cart, right? You can go straight to the shopping cart, or you can go through a product page, add it to the cart, and it drops you into the cart. We want the machine to learn that on its own and learn all the different ways to get to a shopping cart. Because if we let the machine learn like humans do, it won't be brittle. If the shopping cart button goes missing on the home page, the bots will still figure out how to get to the shopping cart and accomplish the test case. So how do we build this robust way of executing tests, and how do we train it? How do we train this little machine? What we do is we start giving it with 0 points, and we say, okay, well, let's start on the home page. That makes sense. and then we let it take a rent, and then we drop a reward. And we say, if you get to the shopping cart, you get a coin, like congratulations, robot, right? And so we let this do this many, many times. So here's our hero, bot. He starts on the home page, but the first thing he does is he goes to the product page, right? We say, it's not really bad, robot. You get -1 points for going somewhere you didn't have to necessarily. You didn't find the cart right away. You lose a point, but you can take another step. When it takes the next step, it goes and says, boom, I went to the product from the product page and went to the cart. And so I hit the goal. We give the robot 100 bonus points for hitting the cart page. And so its net score was 100 for getting there minus the 1 extra step it took that it probably may not have needed to, right? But now it knows how to get to the cart page. It has a path, and it knows it has a score of 99. So then we let the robots train again, another epic or another training iteration. It starts on the home screen, but this time it goes straight to the cart. And we go, really good robot. We don't penalize it at all, and it went straight to the shopping cart. And so we give it 100 points for finding the shopping cart. And because it didn't lose any points, its full score in its mind is that, hey, I get 100 points if I go straight from the home screen to the shopping cart. So it now knows 2 different ways to get to the shopping cart. It's discovered them on its own without us telling the machine explicitly how to get there. Like in current functional procedural code, you tell it exactly how to go there. We're teaching the brain, that test execution bot, much like a human knows, there's multiple ways to get to a cart. Some are better than others. And then we do this in practice. We let these training epics, we give it about 10,000, like literally 10,000 attempts to walk through the app in various ways and learn and build the intuition of how to get to the shopping cart. And that is just one step in a test case, right? Say, go to the shopping cart. It took all this work. It's a lot of work up front. All the classifiers to learn what shopping carts and what shopping carts are and cart pages and login buttons and all this other kind of stuff. And then we do a whole nother thing where we do tens of thousands of training iterations per step in each test case to do the test sequencing. But the good thing is it doesn't require human labor. It's just CPU and compute. So here's kind of a quick overview of this flow in practice of these 2 different parts. Remember, we're combining classic kind of neural nets and using them as classifiers and to recognize what's on the page, and that's on the right-hand side here. And on the left-hand side, we've just told the machine in very simple language, go to the shopping cart. And we've let it train 10,000 times on how to accomplish that step. And then it knows that logic. It looks at where we are on the page, and it knows what the next step is. How are we going to get to the shopping cart? And it does this in basically a complete loop until it accomplishes the test case. So again, it's looking at the app, seeing what pieces are in there, just like a person would, what things are on the page. And then it has a mission, and it wants to get to a particular part of the app, and it has an intuition of how to get there. So it basically can now execute a test case much like a human. And we'll get into more details on like why this is probably I'm pretty sure this is the most complex way to write a single step in a test case, an automated test case. But we'll see the benefits it has later. So here's a quick view of talking about automatic exploratory. So you can imagine the bot, not only can it execute an individual test case, but it can also just look at an app. If I told a human being, like, just go around inside the app and test it, right? Just test it for a little while, test it for an hour before we launch or something. In this case, it's a weather app. Well, the bots can also work much like a human does. So what happens is on the top here, the brain looks at the screen just like a human brain, but the bot brain goes, oh, like that's a search box, right? And I'm in a weather app. And so it takes that data and it looks up from a common there's a library of thousands and tens of thousands of flows, like things that people do in apps, right? Abstract representations of, like, say, add a product to the shopping cart and check out, or search for weather in a particular city. So we've got this giant library of test cases, but it matches it. So it says, give me a test case that's related to weather apps and a search box, and it goes and finds one, just a simple query. And then it says, and then step 1 of that test case, for example, would be enter Redmond, Washington, or something for the location, right? And it will enter Redmond, Washington into an app. And the key thing is because it's abstracted the application, this exploratory stuff can work on every weather app. Like literally every weather app that has a search box, this test case can be executed for it without hard coding or rewiring or rewriting. I just show you, like, people always say, like, oh, I want to see this stuff run. It's kind of boring because it's an app, but this is an example of exploratory testing running on the Amazon app. So this is AI. We've just been talking about working in the Amazon app. And what it's doing is just like a human, it loads it up and it says, all right, rather than just explicit test cases, I'm going to test this thing. So it looks at here, it goes, hey, there's a login page, and we have pre-built-in accounts for the bot. But what it did right there was interesting. It couldn't log in. It couldn't log in because it was trying to do a test case with an incorrect password. I believe it was an empty password. And it doesn't expect to log in. So it did an empty password test on its own, verified that it did not log in, recorded the fact that that test passed, and then it attempted a correct login with a valid username and password, and got into the application. And here you can see it's still working around and playing around inside the app. But it's key to note this isn't just random clicking. There's not like, we're not sending 10,000 dumb monkey events to the thing and hopefully click something interesting. This is executing flows that humans have said are interesting, and the AI takes care of the execution and reporting. Another note, a nerd note, is if you've ever looked at normal test automation on mobile today, you realize that this is pretty darn fast, and it is. We did a lot of our own. We also worked on some infrastructure to make stuff faster, but that's beside the point. Let me get out of this. See if I'm smart enough to get out of it. Okay. It's still pending. Okay. So you've seen it kind of running. It's really running. So now what happens, so now what we can do with, now we have AI, is that a human being can actually go and write basic verification tests for many, many applications. So you can write a set of test cases that work on weather apps, set of test cases that work on common, like maps for ride sharing applications, tests for login pages, tests for different types of applications and parts of applications. But those test cases now with AI only need to be written once. So here's the flow from left to right, and it wraps around the screen. Here's an example of the output of an actual AI testing bot. So all we did was tell the bot, make sure, it's called, the test case in the left is called, upper left is called view the weekly ad, right? We want to make sure the weekly ad is in there. And we give it the target shopping app. The AI figures out how to get to the weekly ad by itself. Like literally it figured out how to get there, and it verified that it was in there. So that test case passed, but it literally did this without any hard coding, without any human intervention. It just picked up the app and ran. And you can do that for many, many different types of tests. And also, it's interesting to note here, I don't work with Target. I don't know anybody at Target, but this AI is so easy and the stuff's so reusable. Like I can actually generate, very large test suites for companies I don't even know, because AI is so efficient. So another key aspect here is that AI is reusable. We've kind of been hinting at. So because AI is not hard-coded in the implementation, it doesn't look for CSS selectors, magic ID values, accessibility IDs, or XPaths and that kind of junk in the application, nor do we need to build a separate object model around the application under test. These same test cases can be executed on any app that is just even remotely similar. So here's that one again with a target ad, finding the weekly ad. But guess what we do? The exact same code, the exact same bot, we give it the Walmart app, and it literally does the exact same thing. It went through there just like a human would and found out how to get to the weekly ad, right? And it verified that it's there, verified it's actually in the running application automatically. And you notice they have different flows, right? There's no permissions dialogues here. There are here, and it took fewer steps to get to the weekly ad in the Walmart app than the Target app. So the flows can be different. They don't even have to be the exact same flows, or let alone use the same elements. They have different shopping carts and different flows, and this thing can still get to the weekly ads. So we have this incredible, I think, the key transformative aspect of AI for testing is that it enables large-scale reuse of test artifacts. Here's another example of this is the test case on the left-hand side. It's very simple. It's very similar to cucumber, kind of, it's a gherkin, like little dialect of gherkin, but it's human readable, right? You just say get to search, step type, navigation. And you basically say, go find the search button. And then we say, find the search box, right? And type in the word gradient and then click the search button. So at a very high level, we're saying how to execute a test case. Now, this could be written by, say, somebody at Google, or just anybody in the world can write this very simple flow on the left-hand side, a business kind of definition of flow. It has no connection or understanding of the implementation of the application. But we know that's a good test case for, say, search, like for a web search app. On the right-hand side, again, we see the exact same test case, no human intervention, no nothing involved. We pass it the Google app, and it can execute a Google search. You can search this. It does a search and verifies that one of the search results has gradient in it. A thing of type search result shows up and it has gradient in it. And so you realize it can run on Google, Bing, Yahoo, DuckDuckGo, across all these different apps, completely different flows. Some are as short as 2 steps. Some are as long as 6 steps to accomplish a search. The AI just takes care of it and verifies the functionality without any hard coding. And if you notice in the middle, that middle one on the right-hand side, that flow is actually the website. Everybody asks, like, does this stuff work on web? Works on web. And so the same test case we're seeing here is it's reusable not only across applications, but also across platform. You can imagine a large, again, cross-application. You can imagine you have some basic sets of shopping tests, like 100 basic test cases for shopping apps or retail apps. But they will run on all of the apps. So this was actually kind of a joke, but that's me. What's interesting is that this AI world now means it's possible for me as an individual, single human being, to write test cases for the top, 1,000, 10,000 apps, like that are useful, functionally validating, and stable. So what it means is the AI is basically, a 1,000 to maybe 10,000x multiplier in terms of human capacity versus execution and regression value. So I'm literally, that's when we say at test.ai that we're working to test all the world's apps. I'm literally writing test cases today. So the human writes the test case, right? But the AI takes care of all the execution. So it's plausible that if you have a mobile app today or a public website, it's likely that our bots are already testing your application. So I'm kind of your virtual test automation engineer. You just don't know it yet. So here's just a quick screenshot to give you kind of an idea of the number of test cases that I personally test. This is actually many orders of magnitude more than these, but then the pixels are too small. But you can see here, here's a wide array of applications. This is a quick sample of the apps that our bots have tested, just screenshots from different test cases executing. And we can execute these in mass. But there's no test engineer, I think, on the planet that's tested this many apps yet. But it's only because I have the power of AI and ML to do it. So everyone testers always ask for edge cases, and you go like, okay, well, that's good for common test cases. What about the very specific? There is a snowflake aspect of my application. There's something very specific nobody else has, or we use a weird icon or something. How do we do that? This is just, I'm trying not to be too commercial, but we built some designers. So you can type the test cases in Gherkin, or you can just let the bots examine the entire application, capture pictures of every different thing in the app, all the flows and all the buttons and icons and text boxes. And then you can just drag and drop them into a flow up here on the top, from the bottom to the top, and it creates a test case. As you just drag and drop the element. And you can say, navigate to this part of the application. It could be a screenshot, or it could be an element. Navigate to here, add a particular gesture, and verify a particular thing exists, or a particular text string appears somewhere. So you can tell and customize the bots for any arbitrary test case that you want to execute, not just these basic reusable high-level test cases. To be frank, though, this is an infinite. It's a fractal of complexity. Like, there are some things you still cannot do with this kind of thing. But it's the early days of AI. Things you can't do today are like, make a runtime dynamic ODBC request to find out the price of an item and verify it in real time that's correct in the application. Those kind of things There's still other ways to do automation, but the vast majority of automation can be, functional automation through the UI can be accomplished this way. So quick note on performance. So the bots can also, because they can look at the screen and they can figure out what's on there, like a person, you can tell when the app screen is stabilized. So the bots keep track of, on every single step they take, they keep track of performance timing, not of the API calls underneath, but of the user experience, which is actually what matters. So AI today is actually driving performance analysis as well. So this is where it gets exciting. So when you start to be able to create test cases that can run across such a wide variety of applications, and even your competitors' apps, or maybe you have 10 apps within your company, and you don't know who's the fastest, who's the best, or whatever, because you wouldn't even take the time to write all those test cases. You can now. So here's a quick pivot on some of the data. So we've done test automation on all of these news apps, this sample of news apps. So you got AP News, New York Times, BBC, and this is for the screen. The screen type's called article. So the AI knows, we've trained it, this is an article page, this is a login page, this is a profile page, this is a search page. And so every time in this subset of applications for news apps, every time it sees an article page, it keeps track of the performance of that page load on an article page load and records it per application. But now you can do cool things. You can see a distribution with AI, because you can actually afford to automate multiple apps, not just your own app, but other apps. You can actually see the distribution of performance within your category or competitive set of apps. So if you're interesting, so the funny thing is, like, so if you're the NPR, you might think your app's pretty fast because it's 1.3 seconds to load your articles, but you're getting smoked by BBC and CNN. So that the app team now knows, oh wow, like we could be twice as fast. Right, so that's we've seen in conversations with app teams. This competitive analysis, powered by AI, it makes them think about it, makes them competitive, it makes them actually care about performance and know what is possible. And conversely, if you're at the BBC and you really have a team focused on performance, perhaps, and you're only you're like 600 millisecond page load time, you may want to get down to 500 milliseconds. But you may realize, like, hey, we're so far ahead of everybody else. Maybe we should work on different parts of the application. And from a performance perspective. So because maybe they're slower in login or something like that. So this AI really enables the scale and reuse of tests, thanks to AI, enables competitive analysis. So then one more thing. So a couple other areas of how AI is impacting testing. So testers will usually go, oh, well, it can't really think like me. Like, what about qualitative aspects of quality, right? Like, is it pretty? Is it usable? Is it say trustworthy? Like, very ambiguous things. So I went out, we did an experiment. I took what I thought was the hardest qualitative aspect for humans even to figure out, which is how trustworthy is a given login page, right? Given the audience, this will be interesting. So we went, and this is the ENUS, the English United States App Store, the bots can actually tell. There's I got an article on this, it's pretty interesting, but you can train a neural network with training data. You basically just have a bunch of people look at all these different logins. So we had we have thousands and thousands of different login pages from different applications because we can automate them all. And then we send them out to humans and we say, hey, on a scale of 1 to 10, how trustworthy is this login page? Like, just ask them, and they write their number down. There's not always agreement, there's different opinions, but we collect all that data, and then we can train a neural network on that data. And what we end up with is a neural network that can look at an arbitrary screen, a login screen from an application, and have a good idea, and actually in practice it's better than a human's judgment, of how trustworthy or untrustworthy that login screen is. So if you see on the left, there's a lot of Chinese characters. Basically, it's not that it's Chinese, it's that in the English App Store, these apps have Chinese characters on the login screen. So it's a non-native, it's strings that are not natural or native to the App Store that the app is deployed in, because people in that can't read that. Most people can't read the text, and so it looks maybe suspicious, or they don't know what's going on in this page. They think it's a login, but what are they doing? And I don't know the company. Something they don't. The bots realize that the logos should be familiar in the market that they're in, And the more familiar, like on the right-hand side, you got Nike, Disney, AT&T, or say Google or Facebook. Those are very high confidence in that app store, but there are none of those on the left-hand side. But we can teach with just enough data. We can teach neural networks to give qualitative analysis of the quality of an application. Something that I actually thought when we did this experiment I didn't think it would actually work. But surprisingly, it's actually even easier and works better and simpler than functional testing, like we've seen. So another thing is how is AI impacting testing? So there's this guy, Diani Santiago. He's super smart. He works at Ultimate Software. I highly recommend people search for him on the web. He's got some presentations and papers, academic papers on this. But he's been focused on generating test data. So this could be for a web page, or it could be for API testing. So the idea is, if you have a sample of test cases, like say you have 100 test cases, automated or just defined in a spreadsheet, you can use LSTMs, and we'll show you in a second how that works very quickly. But you can teach a machine to generate the next 1,000 or 10,000 test cases, because just like a person can look at, hey, here's a set of valid test steps. How many ways can I generate new permutations, combinations of those things that will be functionally still valid? So he uses LSTMs for this work. So here's quick. I'll start with this one. We don't have time. It's a whole talk in itself. But basically, there's test cases, right, that do different things with, say, an Amazon product entry for a book. You can tell it, like, here's a set of sequences in the test cases down below, and then it does this. It generates, it reads all those things, generates a model for what valid test cases and what valid test sequences are, and then, and here's this kind of flow. But and you can see in the bottom here, but it generates them. It generates new combinations that are also going to be functionally valid and consistent. So they can see that they can even verify bad functionality, or verify that there should be an error message, for example, if there's no password string entered. But the idea here is that it learns from existing test cases and then goes off on behalf of that tester and writes the next 1,000 test cases for them. So this can be used for API testing and UI testing. It's pretty cool. And then lastly, I just saw this recently. There's a company called harness.io. They're doing some very cool work on clustering log files and production data. So the idea is, if you have just a bunch of data, you can just point the machines at it, and using unsupervised learning, just like, like K-means clustering and such, let the computer identify if there's anything weird in the data. Like, you don't have to tell it. Like today, we write rules, right, and say, like, if there's a log file with the word error in it, and that count of errors as a function of total logs is higher than 5%, which is what the baseline it was yesterday, then flag a warning or something like that, right, for the DevOps team. What harness.io does is they, on the log side, is they just point, they use clustering on the metrics in production. Again, that's a whole nother topic. It's worth, like, a couple hours to dive into deep. But you can see here, if you plot these different types of events that were logged in the system, it's Splunk, because it's Splunk data, but they analyze the Splunk data. It can identify that, hey, these blue things on the right-hand side, like, are kind of one cluster, and then the red stuff is another cluster. So it basically guides and does the first level of analysis on log files for you automatically. In this case, it's just clustering by similarity. But you can see that, hey, there's a group of machines that are behaving one way, and there's another kind of set of machines that are behaving a different way. And one may be good, one may be bad. They may be both good, just different operational modes. But it's a good early warning system for large production systems to use to apply. And basically, you're testing with as an example of testing and doing quality analysis with unsupervised learning. So, kind of in summary, what you take away here is that what AI means to software testing is that it's a new world where, you don't have to write the same test case twice. We can now share and be like actual engineers, and share and reuse test artifacts across teams, across platforms, and have, not rebuild everything from scratch every time. And secondly, also no team really needs to build another lab. You've got, won't dive into this one on this talk, but basically these things all run in the cloud too. So you don't even need to think about having a physical lab. But because the AI can just run in the cloud. So ultimately, if you think about these trajectories, if you look out about 3-4 years, it's plausible that 70-80% of all the automation that goes on in the world, test automation that goes on in the world, and testing that happens in the world, will now be centralized on just across a few companies and a few clouds. So it's the first thing that AI means. AI ultimately, I believe, means that it'll be the centralization of most testing, a lot of the boring testing, but it will be centralized. And then teams can focus on the hard stuff, the hard corner cases that are specific to their Snowflake app. And lastly is that not only can you share these artifacts, but now we can benchmark apps. Like, how fast is your app? Well, you know how fast it is, but compared to other apps, how short is our user flow to get to the weekly ad, right? Well, we know how long it is in our app, but we can also automatically determine and tell that our competitor only takes like 4 steps, where it takes 6 or 7 steps for our users. So maybe we should shorten that flow and make it easier for people to find things in apps. So really, because you can test at scale, you can do benchmarking, and that means kind of a new world for testing and quality. And then lastly, if you want to connect, I'm pretty nerdy. You can just email me at jason@test.ai or on my LinkedIn. And I usually, on LinkedIn, I get back usually in a few days, and on email, usually same couple days. If you have a weird question or a thought or want pointers, I'm happy to share, because it's a new world of AI. It's early days, and we need to collaborate and share as much as we can to save ourselves from the drudgery of what is normally software testing and test automation.